Hello everyone, this is Anubhav Singh. If I'm audible, please let me know quickly in the chat and then we'll start. Hey guys, hi, I'm Anubhav. I am the Developer Student Club lead at Netaji Subhash Engineering College. That's a college in Kolkata. You might not have heard of the college, but you may have heard of DSC NSEC, which is the group or the club which is conducting this particular event. And it's a series of sessions that we'll be conducting. We are following, as some of you may know, that we are following a proper coursework for this. And since it's taken from a very established book, you might like the coursework. The idea is to have these sessions every alternate day. Um, like we have started on 9th, so you know when to expect the next session. That will be at 10 p.m. on 11th of September. You will always be informed about any of the happenings. We have shared the calendar with you on the WhatsApp group. In case you want to join us, I'll quickly let you know the club deals in making developers out of students. Like we try to impart skills which will be required for you to become a nice developer and develop your own solutions for the society, which help people. So that is what we do in short. And if you want to know more about us, or if you want to join us as a member, then you need to go to dscnscc.com. You might be able to see it on your screen. So that is the link which you go to if you want to join us, or if you want to just know about what we are doing, what you have done in the past. Besides that, if you want to join, Slack workspace, which is where we'll be sharing all the information, as well as when we will be introducing the exercises or the code samples which we'll be doing, we'll be sharing them all on the WhatsApp group as well as the Slack workspace. But the Slack workspace is something which you'll have permanently, which is why we suggest you to join our Slack workspace by using this link. tinyurl.com/tcnsec-slack. So if you join the Slack, and you'll be able to exercises, because we are not going to take submissions on WhatsApp. We'll be taking them on the Slack workspace, and you can all join there so that you're able to submit the exercises that we'll be having in the due course of these sessions that we are having. Besides that, if you want to have rest of the people who are involved in this course right now, who are interested in learning machine learning along with you guys, then this is where you need to go on Intro to ML. It will add you to a WhatsApp group which we are maintaining for all the learners of this particular course. And if you have any issues, then you can post it on the WhatsApp group, and we'll make sure anyhow. We have a huge backing from a lot of people who are the best in the industry, and we believe that whatever problems you have, we will be able to solve them. Maybe it will take us a day or two, but we will definitely be able to solve them, if not instantly. So that was all about introduction to DSC and SEC, introduction to how you can join us and get in a proper communication channel with us. Um, yeah, coming to the program, the Intro to ML with DSC and SEC. You might have noticed that it is open to students of all colleges, regardless of whether they are a member of DSC and SEC or not. So that is entirely up to you, because we just want to have an introduction to machine learning by the students for the students, so that at the end of the day, you as a student have all your doubts clear. Because I don't think there are courses out there which are catering just to students, and especially students in India, because our requirements are a bit different all the time from what we have out there on the courses. And that's why we thought of coming up with our own. At the end of all the sessions, we'll be sharing with you the transcript of the sessions, so that even if you're not able to see the session, you are able to go through the PDF or like the document that we share with you to get a gist, or maybe just to keep a summary of whatever you learned in that particular lesson and prepare for the next one. right? We'll always be sharing you the topics and the upcoming sessions in advance, at least three of them always in advance. So yeah, just hang around in this Slack workspace and WhatsApp group. I'll just quickly show them on the screen. If you want to join them, these are the links. This is for the WhatsApp group, this is for the Slack workspace, and you will be able to get them both if you just register as a member at dscnsec.com. So that done, guys. I'll introduce a speaker for today. That's not me. So that is Ritwk Raha. A number of you might know him. He is the lead designer for Google Developers Group Kolkata. Besides that, he works in image processing, and he is kind of on his way to publish a paper on CNNs and modified CNNs. So, yeah, introducing Ritwik Raha here. And hi, Ritwik.
Hi everyone. Hi Anubhav. Am I audible? Just if I am audible, just give a heads up on the. Yeah, I'm audible, I guess. Yeah, thank you Anubhav for introducing me. Those were some kind words. I don't know when I'll be published, but hoping to be pretty soon. Yes, I am. You might have seen me if you have been to GDG meetups or if you are associated with DSC and SSC in any way. I'm a lead designer and co-organizer at GDG Kolkata, and yes, I am a core member of DSC and SSC. So as Anubhav has probably given you the gist of what this whole exercise and this course is going to be. Well, you know by now, right? This isn't going to be another one of those online courses or MOOCs that you take and just see the videos on screen or read the books and have no proper interaction with the people teaching them. This will really be an interactive session, if you want to call it that. Think of it like this: we'll be sitting in a virtual space, and some of us, I don't know how many of you, but I'm guessing a few of you will be interacting with me, and I'll be interacting with you on discussions, topics, questions that you might have or that I might ask to you, and just uncover the topic that way. And that sounds like a fun way to discover this really beautiful topic. Coming to the Let me just share my screen because you don't want to see my face for the entire time. Just let me know in the live chat if the screen is visible to all of you. Yeah, I guess it should be visible. Okay. So yeah, as I was saying, that this is really not an online, those tutorials that you're going to be taking just to have a linear way of learning, or learn just by looking at the content that is being taught. Think of it like this: when you pick up a book, when you take a book into your hands for the very first time, what do you do with it? Do you just open it up and start reading? Some of you might. I don't always. I take the book and turn it around in my hands. Okay. I take the feel of it. I understand the weight of it. I look at its cover for some time. I understand the contents, and then I start reading. So this is how today's session is going to be. Today's session is, as you can see, it is about uncovering some of the myths and truths of AI, understanding what AI is. And someone is asking, are you from NSEC? Yes, I'm from NSEC. Let's not go into those questions right now. Yeah, as I was saying, this chapter is about uncovering some of the myths and truths of AI, setting the ground facts, and knowing what AI can do and what it can't do, if there exists something that it can't do. Just 1 second. Just let me know if I'm still visible. Cool. Yeah. So as I was saying, we'll be covering some of the ground facts and understand what AI can do and what it can't do, and debunk some of the myths, some of the hype that has been surrounding this. We all know that this is pretty hyped topic right now, and maybe rightfully so. So we'll be, as I was saying, we'll be taking up the book and taking in the feel of it, understanding its weight, understanding the contents, and maybe you know getting some insights from them. I don't know, you will be able to tell me when I'm done. So these are the contents that these are the rough contents that we have prepared, and we are going to be covering them. It's not that strict that we'll have to stick to these. We can cover anything. We can cover anything that you want me to cover or want us to cover pertaining to this topic. Yes. So let's start where everyone starts. Let's start with the introduction. And just before we go into introduction a bit further, let us pause here for a moment, and let us just ask how many of you are into machine learning. How many of you have been practicing machine learning for the last couple of 2-3 months? How many of you have been learning about this topic even for a week or so? How many of you are professionals and veterans? Just started? Shayakda says present, please. Well, Shayakda is a GD on machine learning, and he has been practicing it for the last 3 or 4 years. Well, a lot of people have just started in, and that's nice to see. A lot of people are telling that they are beginners and noobs. I guess we all are. Okay, so moving on. Why are you here? Like, what is it that brought you here? I guess it was a link or a reference or some external links. But what is it that you're doing here? What is it that brought you here? Be honest with yourself. Was it love or passion for this topic? Was it a general interest? Or was it actually because it is a buzzword of this era? If you haven't been living under a rock, you must have heard at least one of these terms: artificial intelligence, machine learning, or deep learning, maybe. So what is it that brought you here? Come on, be honest with me. Interest about machine learning? Yes. A lot of people are saying passion. I saw someone say interest, an urge to learn from the best people. I hardly think I'm the best people, or we are, for that matter of fact. But yes, I guess that covers it. We are all here to learn and in some way understand what these terms mean and what is it exactly that this topic encompasses, if it actually can encompass certain finite area. You'd like to join, or we'd all like to join in about the most talked about buzzword of this era. We'd like to know what everyone's been talking about, or at least understand the essence of it. So that is why this course has been created in the first place. Having an interactive place or a space where you can join in with the discussion and understand the topics, and understand what it is that you're actually curious about. Okay. Also, before we move ahead, this course or this platform does make a few assumptions. It assumes that the readers or the people who are present here, they have some basic familiarity with the syntax and structure of Python. Don't worry if you're not. You're good to go for today. Like today, we won't be going into active coding or writing codes or understanding them in any way. But I guess from next week or next to next week, we are going to be delving into a little bit of coding here and there. So it is nice to have the syntactical knowledge or the structure of Python clear. Uh, we just ask for the basic familiarity with libraries such as NumPy, Pandas, and Matplotlib. If you are, however, at a tad bit uncomfortable with Python or would like to polish up the requisites, uh, here's a link. You can take a picture of it, copy it, note it down somewhere, or just take a screenshot. It is Introduction to Python series by DSC NSEC. It was taken by Anubhav, and yeah, you can go ahead, join that link after you're done with this video, of course. And I guess that will help you with brushing it all up. So moving on, what is machine learning? I'm asking that question. This is not a pause that I'm doing in my talking. I'm asking that question to all of you. I haven't prepared an answer for what is machine learning. So I'd like to know from all of you, what do you think is machine learning? And I know there are some professionals here. So Shaikda, if you would, please don't comment. Yeah, Shaikda has given a very cryptic answer. Rajrita says the story of how machines learn. Anyone else? Anyone else who would like to take a try? Using data to make predictions. Wow, that is actually... Can we get that again? Okay. The question, as you can guess from the screen, is what is machine learning? And wow, there are some pretty big answers. Yes, Shajal has given a right answer. If I meet you any day, Shajal, remind me to give you a 5-star, because that's what you get for answering correctly. Okay. So those are some pretty nice answers, and I wouldn't go into right and wrong just yet, mainly because there shouldn't be a right and wrong to this answer. But yeah, how many of you, and raise your hands if you are one of these, or just say yes in the live chat. How many of you have been in the situation where you're having a discussion with someone and they keep using the term AI and ML interchangeably, right? They keep saying AI in place of ML and ML in place of AI, and they have really no idea what they're talking about. How many of you have been in this situation? Yeah, right? A lot of us, actually. Well, yes, to answer the question on screen, AI and ML are not the same thing. In fact, you can probably say that machine learning is a subset of artificial general intelligence. Researchers are still scratching their heads and trying to figure out what is intelligence and what is the nature of consciousness. So it seems fundamentally wrong to equate machine learning with something so vast as artificial intelligence. Not to mean that machine learning isn't vast, but yeah. So as I was saying, machine learning is, it would be probably right to say that machine learning is a subset of artificial intelligence, where algorithms, as Sajal had mentioned in the chat, where algorithms hold the ability to learn without being explicitly programmed. Just ignore the part, the yellow part about deep learning for a bit now, and focus on the two big circles of artificial intelligence and machine learning. Well, artificial intelligence actually assumes that the program or the robot or whatever, the machine actually holds intelligence and some form of consciousness, if you will. And machine learning is really a set of algorithms that can learn, or that can get better at a certain task with time, without being explicitly programmed to get better. So here's a definition of what machine learning is. Uh, we do like definitions sometimes as engineers. It says machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Someone just, I don't know, copy pasted that in the chat, and someone said something about this, right? So this is a much more mathematical explanation or definition, if you will. A computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. So those are just variables to us right now. I mean, I don't know about you, but the first time I read that definition, I did not make any sense of it. So if you are one of them, don't feel ashamed to say yes, or don't feel afraid to say that, yeah, I don't make any sense from that, because I did not. And I guess a lot of people here who are practitioners and professionals did not make sense of this definition. So let us move into an example, because that's how us engineers and students learn best, right? With examples. Let us take an example. What can we take? Say you're writing a program to segregate images of footballs and cricket balls, right? The task seems pretty straightforward. Footballs look and feel a certain way, and cricket balls look something different, as you can see on the screen probably. You write some rules to classify them based on their shape, their size, the colors, patterns, textures. You can't guess the texture from an image. Well, you can, but let's just assume for this talk that you can't guess the texture. Yeah, so you basically write some rules to classify them based on their shapes and colors and so on and so forth. But your program fails horribly in one case. Your program fails horribly when the test images, or when you test your program on images like this, right? When the images are from, brown baked, muddy and tampered balls from India. So what do you do now? What do you do when you're given images like these? Now, let us imagine for a second that your program is a machine learning algorithm. And from this definition, let us try to equate this definition with this example, right? As I was saying, let us imagine for a second that the program that you wrote to classify these images is a machine learning algorithm. You're giving it images, all kinds of images, and you're telling it which is a football and which is a cricket ball. And this is what is known as training. And you'll get to know this later on in the later courses or series of videos. So this is what is known as training, right? So for example, you're telling that the ball on the left is a football and the ball on the right is a cricket ball. And let us just say, for example, that this ball over here is a football. So you're telling the machine, or you're telling the algorithm, that when balls like these come, or when this ball comes, this is a football. So don't classify it as a cricket ball just because it is somewhat red, right? So you're training the algorithm, you're giving it data on which is a football and which is a cricket ball. And then when you test it, your program or your algorithm is actually experienced on the task of segregating these balls, right? And so when the time comes to segregate this, whether this is a cricket ball or a football, your program will know from experience that this is actually a football, because you have told it previously that balls like this, or balls that resemble this, will be segregated or can be segregated as footballs, right? So that is what imparting experience to a certain algorithm means. Now, when you test it on ambiguous images from any corner of the world, it will be more or less correct, because we have given it loads of experience in understanding what is a football and what is a cricket ball. Uh, just, just someone tell me if you get that. Guys, as I said, this is going to be really a discussion forum. So if you keep quiet in the live chat, I'll take it either all of you have fallen asleep or you're not interested. Yes, that makes sense. To a few people, it does make sense. Good. So moving ahead, why did we opt for machine learning? Why not regular programming? What's wrong with regular programming that we had to go from regular programming to machine learning? Well, the previous example, this example, kind of answers that question. Programming based on a set of instructions and rules or conditions is exceptionally useful. But while solving some real-world problems, we may come across cases where we would like to identify patterns or have a way of continuously tune our set of rules based on the kind of data it encounters. Maybe we are not sure what kind of data we'll be getting. Maybe the environment is fluctuating, or maybe we need to understand the patterns or connections in our data to get meaningful insights. This is when, or rather, this is when you use machine learning. These are some of the cases when machine learning is really great to use. Yes, someone called I Understand, nice name, says that a ball can have numerous features to recognize them. We can't hard code all of them. Yeah, that is perfectly correct. So moving on, what are the let us just briefly ponder upon what are the types of machine learning algorithms out there. As you progress through the course and as you delve further into this series, you'll find there are numerous numbers of machine learning algorithms and systems. So it is good to have a broad classification into some primary categories. Well, they can be categorized like this: whether they need supervision or not, or whether they do not need supervision, like whether these algorithms are getting their experience from human, like with human supervision or without human supervision. That is one way of categorizing them. Whether they are learning incrementally on the fly or learning otherwise, which is batch learning, and whether they are comparing new data points to known data points or detect underlying patterns in the training data. Well, these are a lot of terms that, sounds just goes over your head if you're beginning or if you're starting out. Don't worry, because if all of these sound gibberish to you right now, the idea is to give you the briefest overview and prepare you for what is to come. You'll discover these terminologies and what they exactly mean later in the course, and you'll get the math. And when the math gets too heavy on you, you can come back to these basics and have a sort of ground truth for yourself and know that you have to work from there on. Because as we progress further, and at a certain point of time, you will be dealing with, I don't know, 4 or 5 algorithms at a time, comparing one with another, and the math can get too heavy on you. So it is best to have a sort of safety net where you can always come back and look at and draw insights at what it is that got you started and how exactly these classifications are going to help you, right? So yes, as I promised, the brief history of machine learning. The next part is actually the growth of machine learning. And as always, to understand a subject, we must go back to the very beginning of it. How did AI come to be? What was the first spark that ignited the question of AI and whether AI was possible? They say, well, you can see on the screen a very pixelated timeline of what machine learning is. And don't you worry, I'll go and give you some of the very basics and drive you through the history, if you may. Right, if you have had your fill of looking at the screen at this very pixelated image, moving on, they say that artificial intelligence started here. They say that the roots of artificial intelligence were set in ancient Greek, where this man, not a man actually, this is an android, a bot, where this Talos, his name is Talos, was a giant bronze man who guarded the island of Crete by throwing stones at the ships of unwanted visitors. If you have been to DevFest 2019 and you've heard Anubhav's talk on Web for AI and AI for Web, you have probably seen this example, and you have seen him talk about how this is a bad AI, because a good AI would have been able to differentiate on which people to throw stones on and which people to not throw stones on. So yeah, this is just a fun fact. This is where artificial intelligence, or the roots of artificial intelligence, started. Fast forward to a couple of millennia, and this guy changed history, or AI history as we know it. Well, not this guy exactly. I made a mistake over here. Yeah, this guy. Alan Turing invented bomb machine to decipher Enigma's message. If you don't know what Enigma is, or if you haven't heard of Enigma or Alan Turing, I recommend you go and see this movie. This is a particularly favorite movie of mine, and I absolutely love it. And I guess you will too, since you're starting with artificial intelligence. Yeah, so as I was saying, Alan Turing invented the bomb machine to decipher Enigma's message. Enigma, as I said, if you don't know, well, Enigma is a machine that used to make the messages that the Germans transmit during the war, or use cryptography to encode the messages that the Germans were transmitting during the war. And the British and the Allied forces, they had a really hard time breaking those messages. And if you could not break those messages, you could not find the location of the ships, of the planes that were going to drop the bombs, maybe. So yeah, that was a really huge problem. And this British mathematician, Alan Turing, invented a machine which could decipher those messages. And later in 1950s, he published Computing Machinery and Intelligence, which considered this question. Take a long, hard look at this question. Okay, this is the very beginning sentence of that paper that Alan Turing published. And this proposal later came to be known as the Turing test, which measured machine intelligence or artificial intelligence. So this is really the Bible for us machine learning engineers. This is where it all started. And a couple of months later, when you are actually practicing machine learning, you'll come back here and you'll probably get goosebumps after seeing this quote, because as I said, this is Bible for us machine learning engineers. Moving on, the subsequent years saw the growth of AI research and algorithms to successfully play checkers, and humanoid robots were crafted. And a certain programming language called the Lisp was invented by John McCarthy. He was also one of the founding fathers of artificial intelligence, along with Alan Turing. And you can look him up on the internet, Google him, and you'll get to know some pretty great facts about him. Right. So a little bit about how all this came to be. Well, Alan Turing, he proposed this idea. He ignited this flame, right? But that wasn't the final stroke that ignited artificial intelligence as we come to know, right? Because at the same time, there was this incredible amount of research on neuroscience, on how our brains actually work. And there was an incredible amount of research on algorithms and computing, just mathematical computing, and all three of these are a, a set of all these disciplines came together, and gave that is what gave birth to AI as we know it today. But that everything's not so good. Soon afterwards, there was a lapse in this research period known as the AI winter. There were two AI winters, and I would like to pause over here for just a second, and I would like to understand or take from you why is it that there was an AI winter. Just to tell you again, the these these incredible amount of algorithms and languages were discovered, and a few decades later there was this AI winter where there was this last lapse of good research and good follow-up. Why was there an AI winter? World War? No, there wasn't a World War on 1973. Lack of data and computing power. That's a pretty right answer. Maybe due to World War. No, I guess WW means World War over here. No, it wasn't due to World War. AI is considered bad for humanity. Who are you, Elon Musk? No. Lack of computing power. So I see a lot of few people coming over here and commenting that it was because of lack of computing power. And that's exactly correct, right? Because these algorithms, computational power could not match the requirements of these novel algorithms and techniques. Researchers, and more importantly, funders, started losing trust, having seen no implementation for about 30 odd years. And that was the primary reason behind the AI winter. And yeah, data too, because we did not have open source data like we do now, or maybe in the 1990s. And I will slowly go into that, but let us not fight in the comment section, guys. Some people thought it was because of the World War. Well, that is primarily because Alan Turing discovered his machine in the World War, and that had something to do with the answer. Yes, it was costly to create good data, and it had something to do with computational power, because machines or computers that we do have right now, they do not even match the computers that we had back then. We were just seeing first generation computers back then, and Intel had just released their first set of microprocessors and controllers, and they could not match the requirements that these novel algorithms of artificial intelligence needed. So in 1990s, or just before 1990s, we saw the advent of AI again with IBM's Deep Blue defeating the world reigning chess championship. If you want to read about it, just go ahead and type IBM Deep Blue after you finish this video, and you'll know about what the hype, or how the hype started again. So as you can see that good algorithms and implementation of good algorithms, or maybe the mathematics behind good algorithms, wasn't always enough to get people interested into this beautiful topic. It was that swoosh, or it was that that essence that AI could do something overwhelming. That is what brought people in and got them interested in this topic. Uh, I'm talking about the 1990s, not the present day scenario. And well, a number of things happened subsequently. The increase of computing power, the fifth generation of processors allowed for some initial funding. By the time we hit the 21st century, Yann LeCun, you must have heard of him. If you haven't, just go search him. Another rock star in artificial intelligence and deep learning universe, combined convolutional neural networks. You'll get to know about all of them in the future videos. With recent backpropagation theories, and he developed an algorithm to read handwritten digits. And by the time we hit 2000s, the United States were already using this algorithm to read handwritten checks and zip codes, right? So we had already seen the prophecy turning point. Machine learning research combined with the power of web technologies, open source data, and computing power, it has it hasn't looked back after that. Like after 2000 or 2001, we haven't really looked back. And from 2012, we have this deep learning revolution, and yeah, it's flourishing beyond any of our imagination right now. So I'd like to pause over here again and give you some resources or links. Um, yes, Jan LeCun's deep CNN worked well in during the 1990s as well. Yes, it worked, and that is why I said 1990s, 2000s, and then 2012. That these years added up and led to the revolution of AI as we know it. Okay, I'd like to pause here again and give you some resources that helped me immensely to understand these topics and know about the recent state of the art or the brief histories that that went into crafting this topic. One, if you have been to DevFest 2019, you have probably heard Anubhav's talk on AI for Web and Web for AI. It was a wonderful talk, and you can just search on the GDG YouTube channel and get it there. It's posted. And the next is Artificial Intelligence podcast by Lex Friedman. It is it is a set of wonderful podcasts or interviews that this researcher, has chosen to record, and they are about an hour or so long each, and they are on Spotify, YouTube, iTunes. If you wish to listen to them, or if you wish to know, yes, the links will be shared in the description, but you can just take a screenshot or uh, search for these on YouTube and you'll get all of them. I am sure Anubhav will post the links once this video is done. So yeah, moving on further, what are the possibilities of AI? What is really artificial intelligence and machine learning capable of? And I'd give a long pause over here and ask or play around with some of you and ask, what do you think is possible? And don't give me generic answers. Give me answers that you feel like, that that are the possibilities attuned to you. I see a lot of you going quiet. Any particular reason for that? Do you think that there are no possibilities of AI? Come on, go ahead. Just comment in the chat box that what is it that an AI or artificial intelligence or machine learning algorithms are capable of? What are the possibilities and what are the limitations, if any? Anubhav has posted, I'd create something that could help detect critical diseases early on. That is a pretty novel idea. Infinite possibilities, yeah. Thank you for reading from the screen. AI equal to human brain, I think you're talking about artificial general intelligence. Visual understanding of scenes, Ayush, high five. That is one of my personal goals as well. We can send AI robots to other planets instead of humans. Thank you, Elon Musk, for coming to this chat. Yes, yeah, no, I'm just playing around with you. Yes, that is one of those possibilities. No limitations, Piyush. Is that correct? Self-driving cars in India, ultimate God level possibility? Yes, but that is not God level. Increase business efficiency, right? Good. Okay, it can reduce human work. Wrong data might lead to wrong models and hence predictions. Ankita, I believe you're talking about the limitations. This does not seem like a possibility. One day there will be no work for man, there will be only machine. Engineer spotted. Save time. Okay. Thank you for those inputs. Yes, some of those were really, eye-opening for me. Uh, it is hard to imagine an industry that will not be transformed by artificial intelligence in the coming future, or is not considerably affected by it. Some devices or industries have been using such algorithms for years now, without us users realizing it. That is the extent to which these technologies have surrounded us. With machine learning and artificial intelligence in general, the possibilities are truly infinity and beyond. Some of the use cases, as you guys have already pointed out in the chat, are what do you think? I'm going over what I think. Pattern recognition is some of the use cases. A few of you pointed out that we can, find features and patterns from data. It is tedious and difficult for us humans to look for, minute patterns. Uh, it is generally well fitted in understanding hidden patterns and generalizing them for the data we have. Resource scheduling is one such possibility. A number of industries need to schedule resources smartly. For example, hospitals or schools, machine learning algorithms can come in handy over there. There is also, let me see, safety systems, automatic driving. Someone mentioned automatic driving in Indian roads. I don't think that is possible just yet, but yes, automatic driving, path planning, disaster management, these are some of the key areas. Automation is an industry. Someone said that no more work for us human beings. That is one such area that can help us. As mentioned earlier, a good AI can deal with fluctuating environments. This is a particularly useful skill when it comes to automation. Having to deal with unexpected changes is an integral job of automation industry. And machine efficiency, AI can help improve the efficiency and control mechanisms of machine. They can analyze faulty behavior and draw correlations. And really, someone said, or as I said, the possibilities are really endless. And think of some possibilities. Think of some as number of you have thought of possibilities and have listed them, and wow, boy, do I need an AI to read all of that. Okay, just let me take a second over here and go through all of these. Reduces human error, smart automation, nuances of human emotions might be a limitation. Good. Studying behavioral patterns to predict psychological treatment for patients in mental asylum. Now, that is a bad use of AI, because you're actually predicting who might be a psychological patient beforehand, and if you get that wrong, God save you. Understanding speech of other animals like chimps, yes, can be a possibility. I think you may also like to enlighten everyone about the situations when one should try classical approaches to AI and not ML at first when solving a problem. Just a suggestion. Yes, as I said, this video or this course is just the beginning, and we are really taking or picking up the book, taking the feel of it, understanding the weight, going through the contents, and playing with the ball in general. These are topics that will be uncovered in the later videos and will be discussed upon. Limitations, yes, I won't read that out loud, but yes, that is correct, Shoharda. Machines will create their own language which we will not understand. Wow, that a limitation? Is that a prediction? Is that fear? I recently worked on an ML model that predicts live spam from environmental conditions. So that is a possibility as well. Yes, nice one. Okay. Yes, as as we can see, you guys have listed really numerous number of possibilities, and I need to go through some of these because these really look promising to me as well. And yeah, limitations, well, we are limited, or AI or artificial intelligence and machine learning is limited somewhat even today. The very fundamental basis for machine learning is math. Algorithms determine how to interpret data by using math smartly. In the later chapters, you will come to know that algorithms process input data in specific ways and create predictable outputs based on the data patterns. What isn't predictable is the data itself. The limitations to the power of machine learning algorithms are primarily the nature of the data it sees. The better, and we will discuss the exact metrics of calling data better data. So as I was saying, the better the data, the better the performance of the algorithms. So I'm a little bit surprised that not many of you mentioned that we artificial intelligence and machine learning algorithms are limited by their data. Okay, the second limitation, as a few of you mentioned, is how fast the hardware can compute the data. Even mundane primitive operations like addition or multiplication are performed a gazillion times, a billion, trillion times in such algorithms. The need to speed up the operations is therefore primary and in a way fundamental to the overall performance. We are taking some help of some references and books for this course. And one such book cites, when you begin to realize the importance of the environment to machine learning, you can also begin to understand the need for the right hardware and the need to balance the right result. The current state of the art systems actually rely on graphic processing units, GPUs, to perform machine learning tasks. Relying on GPUs does speed up the machine learning process considerably. So you will be slowly broken into what GPUs are, what CPUs are, and how computing power is an essential way or is an essential bottleneck to the limitations of machine learning algorithms and artificial intelligence in general. So yeah, as I guess we have covered pretty much everything over here, and that was everything on my side. Thank you guys, and if you have any questions, I'll give 5 or 10 minutes to answer them. Or no, I'll take a couple of minutes to answer them, and then we can have Anubhav on screen again. Guys, any question, anyone? Nature of the course, how is it going to proceed? And the topics we covered today. Someone keeps mentioning machines take over the world, AI becomes evil. That is a doubt, that is a question. It is not a question right now. With our current understanding of artificial intelligence, you don't need to worry about that. How do you suggest me to start learning machine learning by myself? Well, isn't this course or this YouTube video for that only? What we will be doing in the next lecture? Okay, that is an interesting question, and yes, I should have answered that. In the next lectures, we will actually be going into understanding data and a peek into the future of artificial intelligence, and just a brief overview of what this course is going to be. This introduction part will just last for a couple of days now. I mean, day after tomorrow, you'll have your session on understanding data, and then day after that day, you'll have your session on a peek into the future. And from after there, you'll get to set up your environment, go ahead into Python for data science. Will it be interactive sessions through coding? Yes, it will be. What is the process by which you will be teaching us ML? Marshmallow, nice username. Yes, we will be going through this interactive course or this interactive sessions conducted over at YouTube Live. And you can post your questions, your queries in these chats, and our team will be doing our best to answer them. Yeah, and that is about it. Think of it like this: a virtual space where we are all sitting together discussing about this beautiful topic and uncovering it slowly. Someone has asked, can deep learning and machine learning be used for same task, or are they for different purposes? Deep learning is a subset of machine learning, as you'll get to discover in the later videos. And yes, sometimes you can use machine learning algorithms that are not deep learning algorithms for the same purpose or the same task. But yeah, those are really topic for further discussion. Is any type practical going to happen? I do not understand the question, but yes, we are going to be having coding sessions soon, and we are going to be having them live, and you're going to be coding alongside. Course duration, we currently have planned for 7 units. Let me check. Yeah, 7 units, including some project work. So just calculate it yourself. We'll be doing one video every other day. What all languages do we need to learn? Ananita, just go back ahead to the first couple of minutes of this video, and you'll see I have posted a link, or I've posted a link for Introduction to Python by DSC NSEC. So you need basic familiarity with languages and frameworks of Python, and the libraries that you need to know are matplotlib, pandas, and numpy. That's it. Everything else will be discussed. Regarding Python, do we need to go through the basics on our own first, or dot dot dot? I do not answer get the whole question, but yes, you can brush up the basics on your own. I just mentioned what you need to brush up, but you can also go ahead and go to that link and go through the videos, skip ahead and follow it. Okay, if there's no more question relating to the topic, I guess we can have Anubhav back to answer these queries and bring this session to an end.
Hi guys. So that was a great session by Ritwk. Thanks a lot. Ritwk, maybe you can just turn on your camera or something. Yeah.
Yeah,
Hi.
I just realized that. Hi, thank you.
Guys, I was answering these. I was answering these questions you have. The course duration is 2 months. That 2 months will comprise of everything from sessions to completing exercises and submitting them to us over Slack, or else we might just go for GitHub in future. After we tell you how to use GitHub, probably another session by DSC and SEC, not within this particular track, but on a different track. So yeah, if you have any questions regarding the course, please ask me because I am coordinating these things. And there were a few doubts like, are all the speakers going to be from NSEC? No, we are very much open to speakers from different colleges, and even maybe someone among you might be, willing to become a speaker. We are very much welcoming, right? So if you want to cover any of the topics, let us know on the WhatsApp. You have my number. Otherwise, you can just go to the Slack workspace and find me out as Xprillion, XPRILION. So once you do that, you can just let me know what topics you're interested to cover, and we will make a matching between the topics and you and your session time, right? So besides the languages that you might need to learn, for this particular course that we are covering, it's Python, and we will try to stick to Python. We won't probably go to any other language, but if and when needed, we might introduce you to some other languages as well, like the course that we have currently prepared, it does not include anything as such. But you might need to know things like JSON, or maybe you might need to know what XML is. So all these things you might need to know, and these are not languages, but you might need to know the markup, how they are done. Uh, so the Slack workspace link is this. So you just go to tiny.cc/DSC-NSEC-Slack to join us there, and preferably join us on WhatsApp as well. The link to the WhatsApp group is this. If the group is full, then feel free to join in the second group, which is displayed in the description. When you go to this link, you will be taken to a group. If it is full, then check out the description for the link to the second group. Like once the first one is filled, we'll fill the second one. So, okay, Skill Brash, do you have a question? If you have a question, please feel free to put them on the WhatsApp group or on the Slack workspace. We'll make sure we answer out to you. We might not have the answers instantly, but we will contact people who we know who are experts in these fields, and we will make sure that you get your answers. So that's one promise we are going to make to you. If you have any problem or anything to discuss, we will make sure that your question gets answered the best possible way. So, guys, that's 1 hour that we have taken from you today, and we'll be hoping to see you on 11th of September for the next topic, which is understanding data, a 30,000 feet view. Like, we'll be just going through an overview of what data is and how we are, and the things related to data, collecting it and storing it and stuff. Just an overview, and yeah, the time will be the same, 10 p.m. Indian Standard Time, and the session will be taken by another member at DSC NSEC currently, because for the starting chapters we had we just went with the core team, but we are surely inviting you to take sessions with us. NLP, yes, NLP is there down the line. We'll be covering NLP. We'll be doing LSTMs. That's when we'll be coming down to NLP. So, guys, that's all for today. Thanks a lot for joining us. And yes, please do use the links. We'll be putting the sessions PDF in the description after the video ends. And we'll also be sharing all the links and on all the channels, like the Slack workspace as well as the DSC and SSC WhatsApp group. We'll be sharing all links, whatever we mentioned, and we'll also be sharing the follow along of this particular video. So, guys, thanks a lot, and that's a good night from us. Thank you.